We have spent classes up in the abstract layers and 8012 models, protocols, IP addresses. Today, we come all the way down to the very bottom, to the part you can actually hold in your hand, the physical layer, and the cables that carry your data. It is easy to forget, in a world of Wi-Fi and cloud, that underneath every network is something physical and 8212. A cable, a connector, a signal traveling as electricity or light. And the choices made down here matter. The wrong cable can cripple a fast network, and the right one can power a device with no separate plug. So today, we will get practical. We will compare copper and fiber and 80-292 the two great families of cable. We will meet the connectors that plug them in, and we will learn power over Ethernet, a genuinely clever trick that sends electricity and data down the same wire. This is the tangible foundation everything else rests on. Let us get physical. Here is what we will understand today. First, what the physical layer really is. Second, copper cabling. Third, fiber optic. Fourth, how copper and fiber compare. Fifth, the connectors. And sixth, power over Ethernet. Let us begin. Let us anchor on what the physical layer actually does, because it is the one place in networking where the abstract becomes real. Everywhere above layer 1, we deal in data and 8212, packets, frames, addresses, all of it information. Concepts we move around in software. It is clean and logical, but none of that can travel through thin air on its own. At some point, information has to become a physical thing that moves. That is layer 1. Here, bits in A212, the ones and zeros in A212 are turned into actual physical signals traveling down a medium. On copper cable, that signal is electricity, voltage levels representing ones and zeros. On fiber optic cable, it is light, pulses flashing on and off. This is no longer software, it is physics and A212. Real signals in real materials, obeying the limits of the physical world. And those physical limits are exactly why this layer matters. A signal weakens over distance, it can be corrupted by interference, and different media carry it differently. The choices you make here, and A212, which cable, how long, in what environment, and A212 set the real-world performance ceiling for everything above. You can have the cleverest protocols in the world, but if the cable is wrong, the network suffers. So the takeaway, the physical layer, is where bits become actual signals on a physical medium and A212, electricity on copper or light in fiber and A212, and because it obeys the limits of physics, the cabling choices here set the real performance ceiling for the whole network. Let us meet the most common cable in the world. The one behind almost every wired connection you have ever made, an A212, copper twisted pair. The design is elegantly simple. Pairs of copper wires, twisted together along their length. Why twisted? Because electrical signals create interference, and twisting the pairs causes that interference to cancel itself out, keeping the signal clean. It is a clever, cheap trick that has made copper reliable for decades. This is the classic Ethernet cable AN 8525, the one with the familiar plug you push into a laptop or router. Copper cable comes in categories, and the category tells you its capability. You will hear Cat5e, Cat6, Cat6a, and so on, and 8212. And the rule of thumb is simple. A higher category supports higher speeds and better handling of interference, usually through tighter twisting and better shielding. When someone specifies and 8200-200, Cat6, and 8200-200, they are specifying a performance grade, not just a cable. Copper T9Ds. As appeal is that it is cheap, easy to work with, widely available, and any 200 tool. As we will see, an A200 tool. It can even carry power. For short runs inside a building, connecting a computer to a wall port or a switch, copper twisted pair is the sensible default and the workhorse of local networks everywhere. So the takeaway, copper twisted pair is the everyday Ethernet cable and A212 pairs of wires twisted to cancel interference, graded by category like Cat5e and Cat6 for higher speeds, and A212, cheap, easy, and the workhorse of short indoor runs. Now the high-performance alternative, which carries data in a completely different way, an 82112 fiber optic. Instead of electricity down copper, fiber sends pulses of light down thin strands of glass. Because it uses light rather than electrical current, it is immune to electromagnetic interference. It can carry vastly more data and it can travel much farther without the signal degrading. It is the technology behind the internet and 39 as backbone and long-haul links. Fiber comes in two main flavors. Single-mode fiber uses a single narrow path for the light. This gives it the very longest reach, an 8212 kilometers and beyond, an 8212, and the highest capacity, which is why it is used for long-distance and carrier networks. It is the premium, go-far option. Multi-mode fiber allows several light paths at once through a wider core. It works over shorter distances than single mode, but it is cheaper, which makes it a common choice inside buildings and data centers for high-speed links that do not need to span kilometers. So the trade within fiber is reach versus cost. Single mode for the long haul, multi-mode for shorter, cheaper high-speed runs. Either way, you are sending light through glass and 82012, fast, far, and clean. So the takeaway, fiber carries data as pulses of light through glass, immune to interference, and able to go fast and far, and 82112. Single mode for the longest distances and highest capacity, multi-mode for shorter, cheaper high-speed runs. With both cable families in view, let us weigh them directly, because choosing between them is a real everyday decision. Copper, though 190 says strengths are cost and convenience. It is cheap, easy to install and terminate, available anywhere, and an A2i200. Uniquely an A200 I200 can carry electrical power as well as data, which we will get to. Its weakness is reach and resilience. The signal fades over distance, limiting a run to about 100 meters, and being electrical, it is susceptible to interference. Great for short indoor hops, not for going far. Fiber and 39 strengths are the mirror image. It is faster, it travels far greater distances, and being light through glass, it is immune to electromagnetic interference entirely. Its weakness is cost and handling. Fiber and its equipment are more expensive, and the glass is more delicate to install and terminate than copper. It is the premium choice you reach for when distance, speed, or interference demands it. So the practical division is clear. Use copper for short indoor runs and 8212. Desks, rooms, a switch nearby and 8212, where cost and ease win and distance is small. Use fiber for distance, for the highest speeds, and for backbones connecting buildings, floors, or data centers. Most real networks use both. Fiber for the long, fast backbone, copper for the finer short hops to devices. So the takeaway, copper is cheap, easy, and can carry power, but is limited to short runs and interference prone, while fiber is faster, far longer, and interference immune but pricier and 80 So use copper for short indoor hops and fiber for distance, speed, and backbones. A cable is only useful if you can plug it in. So let us meet the connectors that terminate these cables and 8112, the ends you actually handle. For copper, the connector is the RJ45. This is the familiar rectangular plug with a little clip that clicks into place on the end of every Ethernet patch cable. You have plugged one into a laptop, a router, a wall socket, and 8012. That click is RJ45. It is so ubiquitous that most people picture it when they think an 840 cent network cable, an 840 cent, one connector type covers virtually all copper Ethernet. For fiber, there are small precision connectors, and two you will meet most are LC and SC. These terminate the delicate glass strands and align them precisely so the light passes cleanly from cable to device. LC is the small, common one you will see on modern fiber equipment. SC is a slightly larger, older push-pull style. You do not need to memorize every detail and A212. Just recognize that fiber uses these small, careful connectors rather than the chunky RJ45. The practical point is simply to recognize them on site and know what they pair with are. J45 means copper Ethernet, LC or SC means fiber. When you look at a switch or a patch panel, the connector type instantly tells you which kind of cable and link you are dealing with, which is genuinely useful when wiring or troubleshooting. So the takeaway, connectors terminate the cable and A212. A J45 is the familiar clicking plug for copper Ethernet, while LC and SC are the small precision connectors for fiber and A212, and recognizing them tells you instantly whether a link is copper or fiber. Now, a genuinely clever piece of engineering that solves a real everyday problem, an A212 Power over Ethernet or PoE. The idea is simple and powerful. Send electrical power and data down the same Ethernet cable at the same time. Normally, a device needs two things to work: an A12 a network connection, and a power source, an A12 meaning two cables, and often a power outlet nearby. PoE combines them, so a single Ethernet cable delivers both the data and the electricity the device needs to run. No matter that is so useful. A security camera up on a ceiling, a Wi-Fi access point on a wall, an IP phone on a desk, an AT20 with PoE. Each needs just one cable run and no separate power adapter or nearby socket. That dramatically simplifies installation, especially in places where running a power line would be awkward or expensive, like a camera in a far corner of a warehouse. One cable, and the device both talks and powers up. PoE works over copper. Because copper can carry electrical current and 812 power. This is one of copper 39 squared advantages that fiber cannot match, since light carries no power. A PoE-capable switch supplies the power down the same wires that carry the data, and PoE-capable devices draw it. It is a small idea with a big practical payoff, and it is everywhere in modern building networks. So the takeaway, Power over Ethernet sends both power and data down a single Ethernet cable, so devices like cameras, access points, and phones need just one wire and no separate power supply, and AT11, a copper-only trick that hugely simplifies installation. Let us make one physical limit concrete, because it drives a great many real cabling decisions, and 85 how far a single cable run can actually reach. Copper Ethernet has a well-known ceiling. A single run tops out at around 100 meters. Push beyond that and the electrical signal degrades too much to be reliable. This is why, in a large building, you cannot simply run one long copper cable from end to end A212 out. You have to place switches along the way, each within 100 meters of the next, to relay the signal. That 100-meter row quietly shapes how buildings are wired. Fiber, by contrast, reaches 4 kilometers. Because light through glass loses strength far more slowly than electricity through copper. A single fiber run can span an entire campus, connect buildings across a city, or carry the internet and TCP backbone across long distances. Where copper measures its reach in meters, fiber measures it in kilometers, and 812, a difference of orders of magnitude. This is often the deciding factor. When the distance is short and A212, within a room or a floor and A212, copper is fine and cheaper. But the moment you need to cross a large building, link two buildings, or go any real distance, copper simply cannot do it, and fiber becomes not just better, but necessary. Distance alone frequently makes the cable choice for you. So the takeaway, copper Ethernet reaches only about 100 meters per run, while fiber spans kilometers. So distance often decides the cable, and A212, copper for short hops, fiber whenever you must cross a large building or go any real distance. Let us turn everything into a simple decision guide. So faced with any wiring situation, you know what to reach for. For a short indoor run to a device and AT212, a desktop, a printer, a nearby switch, anything within about 100 meters and AT212, use copper twisted pair, something like Cat6. It is cheap, easy, and more than fast enough for the job. This covers the vast majority of everyday connections inside a building, So copper is your default for the last hop to a device. For long distance or a network backbone, an 80-12-volt linking floors, connecting buildings, or any high-speed cord that carries lots of traffic over distance, an 80-12-volt use fiber. Its reach, speed, and interference immunity are exactly what a backbone needs, and it is where the extra cost is clearly worth paying. When in doubt about a long or heavily loaded link, think fiber. And when the device also needs power, an 8-hua Tatuhan Taos, a camera, a wireless access point, an IP phone, and 8-hua phone use PoE over copper. So one cable delivers both data and electricity, and you avoid running a separate power line. Match the cable to the job. Copper for short device runs, fiber for distance and backbones, PoE when power must travel with the data. So the takeaway, choose by the need, an 8-12-4 copper twisted pair for short indoor runs to devices, fiber for long distances and backbones, and PoE over copper whenever the device also needs power, and most real networks combine all three. Before we close, let us step back and see why this humble physical layer deserves real respect from anyone serious about networking. Everything an 82.1, every protocol, every packet, every clever piece of software up the stack, and 82.1.12 ultimately rides on these physical cables. The fastest processors and the smartest routing mean nothing if the signal cannot get down the wire cleanly. The physical layer is the foundation the entire tower of networking stands on, and the weak foundation limits everything built above it. This is why cabling choices have real, lasting consequences. Choose the wrong category of copper and you cap your speed. Run copper too far and you get errors and mysterious slowdowns. Skip fiber, where distance demands it, and the link simply will not work reliably. Many baffling network problems that look like software issues turn out, in the end, to be a physical layer problem and 8200 will. A bad cable, a run too long, the wrong medium. So a good networker never dismisses layer 1 as NA-A2 under 20, just cables NA-A2 under 21. They know that getting the physical foundation right, NA-A2 under 12, the correct cable within its distance, with the right connectors, powered when needed, and 8212 is what lets everything above it perform as designed. Respect the wire, and the whole network rewards you. So the takeaway, every layer and protocol ultimately rides physical cable. So the physical layer is the foundation of the whole network, and 8212. Getting the cable, distance, and connectors right is what lets everything above it actually perform. And many an 8280 software 880 sign faults are really physical ones. Let us gather the whole class in one breath. The physical layer turns bits into real signals on a real medium, an 8-hua pole, electricity on copper, light in fiber. Copper twisted pair is everyday Ethernet created by category like Cat5e and Cat6. Fiber carries light, and 8012 single mode for distance, multi-mode for shorter runs. Copper is cheap and short range. Fiber is fast, far, and interference proof. Connectors and 8212 are J45 for copper, LC and SC for fiber. And PoE sends power and data down one cable. So a device needs no separate power supply. Next class, an 80 or 12 switches up close and how the LAN really forwards frames. One idea at a time. That is the physical layer, and 8210, the real, tangible foundation beneath all the abstraction. Copper for the short, cheap hops, fiber for distance, speed, and backbones, the right connectors on each, and PoE to power a device down its data cable. It is easy to overlook, but every bit you will ever send travels down one of these wires, and 8212. So knowing them well makes you a more complete, more practical networker. We will see you in the next class.